Hello students, today we'll be talking about differential equations. It is of two types, ordinary differential equations and partial differential equations. Ordinary differential equations are those which involves one or more derivatives of an unknown function. So in these equations, the independent variable is only one, whereas when we talk about the partial differential equations, those have more than one independent variable. So here you could see y is the dependent variable and x is the independent variable. So in the common real life situations, many problems can be represented in the differential equations form, satisfying the given conditions. Mostly we are not able to find their solutions because they are very complicated and they don't possess the closed form solutions. So how do we find the solutions of such kind of equations? For these types of problems, we have numerical methods that we can use. So let us consider the general first order differential equation dy by dx is equal to f of xy with initial conditions y of x naught is equal to y naught. Now how could we find out the solutions of such kind of differential equations? It can be found using either of these two forms. First of one is a series solution for y in terms of the powers of x. So basically we are talking about the power series in x. So these values of y can be determined by substituting x is equal to x naught, x1 up till xn. So the solutions of the such kind of differential equations can be found by the direct substitutions. Whereas in the second case, when we have a set of tabulated values of y for x is equal to x naught, x1 up till xn with the spacing h. H here means the step length. In this case, the solution is obtained by applying the method repeatedly for each value of x. What are initial value problems and boundary value problems? Initial value problem is a kind of a differential equation of nth order in which all the n conditions are prescribed at an initial point only. For example, we have a second order differential equation here in which the conditions are given at point 0. So here 0 is the initial point and we call these conditions as initial conditions. On the contrary, the boundary value problem is a differential equation of order 2 or more for which the conditions are prescribed at more than 1 point. It could be 2 point, 3 point, it depends upon the order. Here in the example you could see we have a differential equation of order 3 and we have 3 conditions. All these 3 conditions are prescribed at different 3 points. So first one is at 0, second is at x is equal to 1 and third one is at x is equal to 2. So this is known as a boundary value problem. Now we have our next theorem which states about the existence and uniqueness of the solution of the initial value problem. So in the upcoming videos, we'll be talking about the initial value problem only and their solutions, how we could find out the solution of the IVPs. So let fxy be a real valued function such that it satisfies these two conditions. The first condition is that it is defined and continuous in the closed interval AB. Second is there exists a positive constant L such that it satisfies this condition where this L is known as the Lipschitz constant. If both of these conditions are satisfied, then for any y naught, the IVP has a unique solution in the closed interval AB. The solutions are determined at a set of discrete points and those are known as grid points or the measure points. The numerical methods to find the solutions of the ordinary differential equation are subdivided into 2 categories. So let us see those categories. The first one is single step method. What are single step methods? These are those methods in which we use only one point to determine the approximation of the next mesh point. Its examples are Picard's method, Taylor series method, Euler's method and Runge-Kutta method. All these methods we'll be discussing in the upcoming videos. The second type is multi-step method. As the name says, in the multi-step method, we are using more than one mesh point to find the approximation of the next mesh point. So here it could be 2 points, 3 points or 4 points to find out the approximation of the next mesh point. Its examples are modified Euler's method, Adam-Bashford method, and Milne's method. So all these methods we'll be discussing in the upcoming videos.